Let's talk about making graphs of frequency distributions now. Graphs are essentially pictures of our data. And it turns out that humans means prefer pictures and graphs over tables of data. One of the goals of making a frequency distribution is to take a large pile of numbers and reduce it to a smaller, manageable pile of numbers. And if we reduce it to a graph, to a picture, it's even easier for humans to read. Humans just don't like large quantities of numbers, and that's why graphs can be so useful. Now, what I want to do is I want to talk about, first of all, how graphs can be used deceitfully. And this is a real major problem with statistics. You've probably heard that there's lies, darn lies, and statistics. A lot of times people use statistics to kind of like snow people and confuse them. I consider this to be completely unethical. Azusa Pacific, where I teach, is a Christian school, and I have very strong Christian convictions also, and I believe that I need to be as completely honest as I can be with people. I don't want to deceive people at all. So if I'm presenting data in a deceptive way, I don't want to do that. I want to be truthful and clear when I present data. So let's look at an example here of how data could be used the wrong way. Let's say that every year there's this large university with about 19,900 students. So that's about twice as big as Azusa Pacific. And and we have data for the last 30 years ago or 20 years ago on the number of students that attend. And if you look at it, it goes from like 19,800 to 19,980, 20,000. These are kind of ugly numbers, but we put them on a graph and we see that they're very flat, very little variation from year to year. And the way that we've arranged this on the y-axis, so it is honest, is we put 0 here and then 10,000 here. So we've got the distance from 0 to 10,000 is the same as the distance from 10,000 to 20,000. The tick marks on the y-axis are equally spaced, and we can see clearly that there's very little variation between enrollment in the years. But unfortunately, sometimes people have enemies. And suppose that the president of this university, who's been president since for 20 years or so, he's got some enemies that want him out. One way that they could create an argument against him would be changing the y-axis and making it kind of deceitful. Here we have the exact same data, but the gap between 0 and 19,800 is very, very small. So it goes from 19,800, 19,900, 20,000, and when we graph the data this way, it looks like it swings wildly up and down. And this could be used by faculty that are against the president to say, oh, this president is incompetent. We can't plan anything. There's too much variation in the student population. Look at how things are. This is such a chaotic university. We've got to get rid of this president. But we know from the previous slide that that's not true. It's actually very stable. But because the y-axis has been changed so that there aren't equal intervals between the tick marks, it looks like there's a huge variation, which is very deceitful to say. So whenever you're presented with graphs of frequency distributions, check the y-axis. Is 0 really 0? Is it showing what it says that it's showing? Check, because a lot of times people are going to try to manipulate this y-axis to be deceitful. Now the most common, or one of the most common ways of presenting a frequency distribution as a picture is the bar graph, or also known as the bar chart. Now when we talk about bar graphs or bar charts, graphs or chart, they're synonymous. The graph and chart mean the same thing. And basically what a bar chart is that it's a plot of the frequency distribution for nominal, so that means categorical data, or possibly ordinal data. And because we've got this nominal data, these categories, we've got to be really clear on the x-axis down here to indicate what these categories are. So we've got the categories down here, And then the height of the bar represents the frequency, how many there are in each category. And then we've got space in between each bar. So here we've got 6 different undergraduate majors, and we've got the number of students in each major. So psychology has the most with about 550, and philosophy has the least with about 100 majors. And you can look at the height of the bar to figure out how many each major has. Now, the way that these 6 majors have been organized is from the most popular to the least popular. There's no reason that we had to arrange them this way. We could have put them in alphabetical order. We could have gone from the least to the greatest. We could have just randomly put them in there. In nominal data, there's not an order to the data, so you can put it any way that you want. But it's important to have this space between the categories because it's not a continuous spectrum going from psychology to communications. It's not like once you've been a psychology major long enough, you become a communications major. No, it doesn't work like that. These are separate categories, so we need the space between them to show that it's not a gradual transition from one to another.